Right, the topic of series and applications, because as I've mentioned several times before, a lot of what about maths is patterns, picking up on patterns and trying to come up with shortcuts based on patterns and so on. So just some definitions to start off with. A sequence, also sometimes called a progression, is just a set of numbers that do follow a pattern. Now, a lot of people call that a series, but that's not what a series is. That's what a sequence or a progression is. A series is when we physically add all those numbers together. Very subtle difference. So if I said 2, 4, 6, 8, that's a sequence. Whereas 2 plus 4 plus 6 plus 8, that's a series. That's a subtle difference. A we commonly use for the first term for obvious reasons. But then terms after that, we use T to represent term and then a subscript of whatever term it is. So I suppose technically A is T1. And then Sn is that series. What does that series add up to? So the sum of the terms. So here's a formula to find any particular term. They want us to find the fifth term, and as you've seen before, it's just a matter of basic substitution, so bang, 27. If we have to work out whether 42 is a term, then we would solve the general term, so n squared plus 2 equals 42, and we want the answer to be a whole number, because you can't have like the second and a half term. So we just have to work out whether n is a whole number. Square root of 40 is not a whole number, so no, 42 would not be part of this pattern. So that one's no good. So that's just series in general. We're interested in two special types. First one we'll look at arithmetic, and the other one geometric. So how do we define an arithmetic series? This sequence is where there's a common difference between the terms. And so that constant amount, adding a constant amount, which we call the common difference, and we use the symbol D for difference. So the difference would be, you could pick any two terms you like, and whatever the difference, so subtract. So term 2 minus the first term would tell us the difference. 3 minus 2, and we could pick any one we like. You don't necessarily have to pick consecutive ones, of course. I could pick the 6th one and the 12th one, and there should be 6 common differences between them. So 6D would equal whatever the difference is. So the difference, so technically we could pick any term we like, subtract the one before it, that would tell us the difference. That brings me to another way of sometimes writing arithmetic series. We could find term 1 simply by adding the difference to term n minus 1. That way of writing it is what's called a recursive formula. So a recursive formula is when you write the formula in terms of previous terms and what you do to previous terms. So term 1 is A. Term 2, therefore, using my recursive formula, it must be term 1 plus a common difference. Term 3, therefore, is term 2 plus a common difference. And that allows us to come up with a generalised formula. A plus n minus 1 differences would be any particular term in an arithmetic series. So I know term 3 is 9, term 7 is 21. What is the formula? What is that general term? So I know, well, A plus 2 common differences is 9, plus 6 common differences is 21. Simultaneous equations, D is 3, A by a coincidence is also 3. So there's my formula, A plus n minus 1D, but of course we can tidy that up. Expand out, simplify, and there it is. So this particular pattern is just multiples of 3. So 3n. So if I now had to find term 100, I can substitute it into the formula I just found, 300. Which term would be the first one bigger than 500? Well, we're saying when is the general term bigger than 500? That's the inequality we want to solve. So 3n is greater than 500. 500 over 3, but remember n has to be a whole number, an integer. So we want the first one that's bigger than 500 on 3, which would be 167. Always interesting, how would you answer this one? Because it says, what's the first term greater than 500? Do you say, it's the 167th term, or do you actually write the number down? I tend to put both just to hedge my bets there. So, well, yes, it's the 167th term, which is 501. That would be the first one bigger than 500. So a quick little recap there.